Hello, everybody. It is Larry. This is Leetcode Weekly 181. Um, yeah, what's there to say? Good luck, everybody. Or I guess wish me good luck because you're on video. Uh, hit the like, comment, subscribe, whatever you want to do. It's fine. But watch. Let me know. Um, Remember that the links in the description so you skip ahead, and hope everyone stays safe out there, and let's do this. 5 seconds. Get my mouse ready. Okay, and here we go. Yeah, problem one. Yeah, I mean, I think this was pretty straightforward. Let's see what I did here. I don't actually, I remember taking like an extra 10 seconds for some reason, but then I don't remember why. But yeah, I knew how to do this immediately. I forgot of one thing that I did have to Google a little bit on because it's been a while is Python insert function. I mean, I knew that it was in there, but I just forget if it was insert or some other weird name. And it turns out it was just to insert. So that made it really easy. Um, yeah. Also, Larry needs a haircut. Leave a comment about that if you feel like it. Uh, yeah, so, and then after that, I feel like I probably don't need to test, but I still test anyway. And also, I forgot to use the use example test code, which use example test cases because I don't know. Double check the answer, and I was like, okay, that's good to go. I forgot to use it because it's new. I think actually the run code should be on the left side now that I know this the workflow, just so that I don't click on accidentally click on submit because I feel like I'm always almost clicking it. But okay, for devices. From here, I was just trying to read the problem a little bit. I was like, okay, this seems pretty straightforward. The problem statement is short. It is what it asks for. The standard factorization algorithm works, so but that's what I'm going to do. I'm going to factor the, well, for factorization, or just getting the divisor algorithm, not the because, yeah. Um, and that's pretty much what I did. I was like, okay, let's just write out the template before the divisor algorithm, and then if you go to 4, then this is actually, I mean, it's just what the problem asks for, and now I just have to write that out. Which at this point I've done probably thousands of times, to be honest. So that's why no rehearsed. Um, I wanted to start from 2, just why not? Even I could have started from 1 on this one. And yeah, and this is pretty straightforward. Yeah, yeah. Oh, and I put in a set so that I don't have to worry about the what you call it, the perfect square case. Um, yeah, and again, I forgot to put use example test cases, though when I did, there was only one test case anyway. I was like, okay, oh, 0. Well, oh, no. But yeah, after printing that out, and I'll just submit it. And yeah, so 4 minutes into problem solved, I was feeling great. And then I went into this problem. Yeah, overall, I mean, I think I knew exactly what to do, which made taking this long on this problem even more painful, to be honest. Because I was like, okay, this is just simulation. Just you don't even. like it's not even a search problem; it's just simulation. So then, but of course, it's not an easy simulation per se. I mean, it's not a hard one either, but also per se. But it's a little bit unusual. But basically, you have to model these, so then it becomes a data structure modeling or coding exercise, and and yeah. But yeah, here I just keep on look at the problem. I was like, okay, what was the best way to model this? But uh, yeah, at this point, I thought that I think I had a and wow, I spent 2 minutes just reading this poem, right? But at this point, I had the thought that like, okay, you have a two-way street, so or not two-way, but well, I guess it is a two-way street. But anyway, a street that has an in and an out, so I could just keep track of the ins and the outs. Um, but if you, and I actually end up, and I removed this because I realized that like road one, for example, it comes from the left and it goes to the right, but it also goes from the right to the left. So because of that, I was like, okay, actually, it's not it's you have to model it as a road thing to have both. And here, I think I talk about this later in the commentary, but in the explanation. But I think one thing that I would recommend uh, for for something like this is I mean, I couldn't do this easily in a switch. Well, one is because I was on a laptop and I'm screening, so I don't know how that interacts with screening. But what I recommend is having, if you have two monitors or just two windows side by side, so that you can do them while you're typing. I mean, you could probably see a lot of typos right now, which end up costing me minutes that I guess we'll quantify in a little bit. But like for example, road one is wrong and stuff like that, where I just have typos all over the place, and I confused for a couple of the streets, the x-y axis, and
Sorry.
like if you look at this, it probably makes no sense as a result because it would just keep a lot of going up and down and stuff like this, and just the actual programming, I think I did pretty quickly, I want to say, but I'm about 7 minutes in, 7.5 minutes in to the contest, and I knew exactly what to do at this point. So I really should not need to take 10 minutes to finish coding. But let's see what we did do here. But that's kind of my general thought. In terms of algorithm, I don't think I have any more new thoughts except for maybe a minor one relatively coming up. I set it up kind of like a BFS that can only go forward. Um, so kind of. I mean, that's how I was thinking about it in my head. But I don't know if that makes sense per se. It doesn't. I mean, I don't think it necessarily made sense. But um, yeah, right now I'm just setting up the end conditions and the transition conditions, similar to BFS, but Uh, but yeah. But yeah. So so now I'm looking at the grid and where I am, and then that's the road. I think I also thought a little bit about like, are there any different cases starting from 0, 0, like the origin, I guess, or the original point? Like does that mess me up? Here, oh, I do this weird thing where, and I spent a couple of minutes on this, uh, where because I put the roads are a tuple of a tuple, I was trying to do this weird thing. Python experts, if you know how to do this in a cleaner way, leave in the comments. But definitely love to learn a little bit better. But I do end up changing it to an array, so that makes it way more sense. But so yeah, now I'm just okay. Given a road, like, and you're going in one direction, I wanted the easy way to check whether the cell you're going to has a road receiving where you're coming from. And I did come up with this inverse thing, and to be honest, I wasn't 100% sure. I mean, I think I had intuition that it was right, and I was like, oh, actually, like so my thought process was, okay, I was like, okay, I have this problem. I have to think about how on a new cell, whether I have this road to connecting it. And I was like, wait, can you, like, using my intuition a little bit, to be honest, and just a lot of practice with these kind of grid problems, I was like, oh, can you just do the negative or the inverse of roads? And it turned out that I could. So then I did. um, yeah, I was very fortunate for that. Um, and I just try to check to see if it's not done. Right now, let's take a look real quick. Um, oh yeah, I also changed it to a for loop so that I know that it terminates and I don't have to check whether we add even one or not. Oh, and right now I just have weird syntax error because I was using intervals and I was tuples, and I was like, okay, I don't think I want to deal with this anymore. Tuples, I don't want to discover learning how to do it. Let's just fix it and change it to arrays. Even though that took less time, or that took more time, or yeah, that takes time now to do, and I should have done it earlier instead of trying to muck around with it. Um, that was just a random variable name that I just try to figure out. And I'm like, oh, actually, then I could just do this, and then the rest should be good. Except I got the wrong answer, and I was like, huh. I think right now, so it's about 13 minutes into the contest or so, 13 and a half. So I spent another 5 full minutes solving this one by adding a lot of debugging and stuff like this. But the short answer is, yeah, I mean, I wish I checked my roads. I think for not this problem because I haven't. I don't have any recollection of doing something similar with this kind of mapping, even though I'm using a technique that's similar to other grid problems. But because of that, I think I was more confident about the roads array more than I should have, because I think if I was doing like like a regular grid problem where you only go up, down, left, right, or something like that, then like I almost never double check that because I type the same way every time, and I've done it thousands of times to be honest. So like yeah, there might be a typo, but stuff like that. But I'm happy that I don't have any more typos to be honest. But I was also worried a little bit about like off by ones because the grid is one indexed, meaning it starts from one to six. So I was like, okay, is that maybe do I have enough by one somewhere where so that's the other thing that I was checking on. But also the same thing that I said earlier, which is that um, if I had them side by side, then I could just do a spot check much quicker. But as of right now, I have to scroll up and down and up and down, and then like, I mean, you see it, and that's why I have issues with this farm, and that took a long time to debug, unfortunately. Yeah, I just wanted to see. I was like, oh, that very coincidentally they have the same thing. So I was like, huh, did I just code the wrong thing in the wrong place? Or I think the other thing was also, to be honest, I got a little confused myself in the debugging. Is that when I print this stuff out, it is zero index. But in my mind, I was looking at the one indexed um, element of roads to check. So I definitely confused myself a little bit there with the zero index and one index and translation. And that's why my debugging is even slower than it already is. Um, and you see me printing out a lot of stuff as a result. Um, Five by six. Yeah, now I looked at this, I was like, oh, wait, these are just wrong. And I had to, as you can see again, I had to scroll up and down and up and down to make sure.
By six as well.
Okay. Yeah, just to kind of double check left and the right, and then whatever. Okay, I solved that one, or fixed that one, fixed that issue, solved that issue, not the qualm necessarily. Ran the test. It looks okay enough for me to submit, so then I do. And very fortunate that it got around the first time. There's a lot of silly mistakes in general.
That took way too long.
Q4. Yeah, to be honest, my immediate reaction, well, maybe not my immediate, but one of my first reactions is that I need a suffix tree or suffix array or some variation of that. But then before that, I was like 100,000, maybe it's fast enough, maybe it's not. So let's just do a naive thing, put everything, all the suffixes in a hash table, and then look that up. think I was just double checking some stuff. But yeah, I'm doing really naive things right now, so yeah. Yeah, and I'm just putting it out. I'm like, all right. Some of that is just always a little bit rusty about the what you call it. Um, but rusty about the pipeline. Yeah. And this is just very standard looking up from a hash table. But I was like, okay, this should work. But the I mean, like it's a naive algorithm, right? And a naive algorithm obviously is going to work for small cases. So I definitely would not let myself So yeah, so I wanted to print out the end just so that I could kind of see the running time and the performance profile. This is something that I do more of in general for the harder contest. But I was like, oh, 13,000, that's good enough. And I was like, wait, no, 10 to the fifth is 100,000. I always confuse 10, like 10 to the x with x thing. I don't know. I'm always off by one in the or by a factor of 10, which is a lot. So I was thinking about it. I'm like, memory limit exceeded. Oh, well. I mean, that makes sense. I mean, it was a hard, right? Like, if that solved it, then, yeah, and people did solve it even now. But I spent a long time on Q3, so. I was just trying to see if I could print out the end just for purposes. But I guess the memory limit exceeded. Doesn't allow to print things. So I was like, okay, back to square one. How do I solve this? So at this point, I'm about 4 minutes in. And right now, maybe even before that, I was thinking about the suffix array, and I was thinking about also maybe some sort of tree type thing, like what you might call it, like a trie. I mean, suffix tree would have been, if I had a library set up, would have probably been the easiest way, just by the virtue of that is literally how that problem solves. So I was like, okay, fine. Let me give it a try doing the suffix array. I do have this one trick in how to do suffix array in C. I think I also could do it in C++, but I figured I'd do it in C. And then, no, no, well, you do it in C++, but in a mostly C kind of way. So right now I'm just looking at some of the previous code I've written and then try to remember how to do this or like precisely, because in C there are a lot of ways you can go wrong. But yeah, right now I'm just looking at my old code that I've written for suffix arrays because that is something that, you know, not practiced enough. But yeah, don't try this at home, everybody. But basically, I do. So obviously, if you, well, first of all, Google suffix string, suffix array, and stuff like this, suffix tree, if you want to learn more. But the idea here is, and there's a linear construction using Okokin. I'm probably messing up that name, but just algorithm. But there's a way where you could just search all the suffixes in C um, by storing their pointers. And I'm not going to get into this too much, but it allows you to, I think it allows you to create a suffix array in n log square n time, uh, where um, n is the number of elements, and it has linear space in this case, which is the thing that I was worried about. And n times log n, log square n is not that slow. So even for 100,000, it's not fast either, though. Yeah, that's essentially what I'm doing here, and I spend, let's see, at this point 5-6 minutes. So this constructs the suffix array, and sorry, I'm a little tired, and I'm trying to figure out at this point how to. I mean, I knew that I needed to do a binary search, so that's pretty much what I'm doing here. Looking it up. Also, I need to set up the answer. For maybe I have a typo somewhere because I end up running into I don't know, a memory error, which I did not want to think about debugging during the contest, so I switched a little bit. I think at this point, the amusing thing is I think at this point I'm still thinking about using suffix arrays, but it's probably not necessary. Well, I mean, it definitely is not necessary, but Uh, Also, if you're watching at home, don't use Malik, use Colic. But some old habits die hard, so, and I'm trying to, at this point, doing it as fast as I can, obviously. Uh, but would not recommend it. And this is standard binary search stuff. Yeah, and I only want to compare the first I characters, but I don't know. Maybe I will go back and debug this actually because I feel like this should be right, but maybe there's some weird memory thing. And also, yeah, maybe there's also I think there's a possibility that I don't know. I don't use C very often in Leetcode, so maybe there's some like platform specific nuances that I would have to debug to figure out, but I didn't have time here. But I think in theory, this is mostly it should have been mostly right. I mean, that, or at least the implementation is what I intended to be. Whether and but maybe not. Maybe this would have been too slow. But at least the way that I did the binary search, because it's a little weird. But I spent effectively 10 minutes on this solution when I could have done it. I mean, some of it is that there will be carryover in the sense that it helps you think about the limits of your problem. But this one was a little bit of like, I ran the sig fault. I was like,
that's gonna be hard to debug.
Just try it for smaller cases, and then I still want any issues.
Is there another way to do this? That isn't.
What a mess. Yeah, and I'm thinking about like whether at this point, I was like, oh, is this really the path I want to go? There's no, and then it took me a long time to realize this, which is a little sad. But I was like, okay, there's no way that they require you to, like, there must be an easier solution than suffix arrays on Leetcode, right? So that's what I was like, okay, Larry, just think instead of wasting 10 minutes on the solution. So going back to Python for a little bit. I was like, okay, what am I doing here? And I realized that you can actually just do it as a sort of a rolling window thing compare. And I was like, okay, you could do it that way. I think rolling hash is one of those things that I'm not very practiced on, so I definitely need to practice on a little bit. But that's essentially what I begin here. I write. This is actually pseudocode. I think that's coming up. I just wanted to make sure that because with rolling, well, just with sliding windows type problems, I run into off by ones a lot. So I wanted to write it out and just really think through which index that I'm adding, and then that's, yeah. And now I'm thinking of yeah, doing the rolling hash. So I was like, okay, let's just code that out a little bit. Uh, yeah, and I was like, okay, let's actually do the even more naive thing, just to kind of check that it works. Though it should work. I don't know why I would, doubted it. I just wanted to see performance timing. I think that was the big thing. Um, and I was like, oh, this is clearly wrong. I mean, this is just a typo, and that's why we need to practice. So I would have the rolling hash one. I would have done it that way, or I wouldn't have done it this way to get it wrong like that. But yeah, afterwards I was like, okay, this looks good for now, or like not good, but like it's obvious why. So let's just put that out. I'm like, okay, that the result looks good, but the inputs are not the big one is the one that I worry about. So let's kind of take a look. And I was surprised that it only took 184 milliseconds for that long. So I was like, okay, let's print out. I was being a little bit careful at this point. Let's print out n just so that I could see what n is. And then I submit, and then it was correct. So I didn't have to do the rolling hash. I was surprised. That's all I have. Talk to that guy. Thanks for chilling. You gotta be kidding me. Okay, well, that's why everyone got so quickly, but I thought you can't do an n square algorithm. That is silly of a problem. Yeah, okay. It's a very slow contest for me, but I did pretty okay on the first few, but I mean, okay. How that took 20 minutes, and I tried. That is annoying. I don't know. I mean, I don't know if there's a. Maybe that's why it's a 6 point. I don't actually usually. No, I mean, I don't think I ever look at the point values because it's not. It doesn't come up here, and I only click on it in the beginning. But, I don't get it. I don't know if it's a Python thing where they do neo matches or something better. I don't know. Maybe there's some sort of like. I don't get it. Like if this is all A's, would that work? I guess so. Oh, well, I am off by a factor of 10, so let's try that. Kind of annoying, actually. I was hoping that would fail, to be a little bit weird, honest. I mean, it passes, but that's silly. Because, I mean, obviously, if that was the case, I wouldn't have took 20 minutes to do it. Why does this have 268 total accepted? Or does that count like the Chinese server or something like that? Or I don't, not sure. What, I mean, I'm 64, but that's a really, I don't know. I have to see what the intended solution is because I was trying to do I'll go over it a little bit. And that's why I was trying to do this thing in C. I also struggle a lot with the problem 3, obviously. Problem 1, I feel like I was doing really well in the first 2 problem. I don't know where I was in the rankings, but there are not that many 3-minute, 4-minute, sub 4-minute, but like with a 3-header. In the first couple of things, maybe I'm wrong, but I felt like I was on a good pace. The third problem, definitely should have done it faster in general. I knew how to do it. I mean, there was not, it was just simulation, but I got confused with the X and the Y axis, so that took a little bit of time to debug. And then the last one was just annoying because I really thought you needed to do something with suffix tree or sorry, suffix array or something like that. But at least the way I did it was dumb, right? Like I don't think this should be correct. At the very least, that's why I had all this other stuff was that at least, I mean, and I could respect people who got it with rolling hash very quickly. I thought about it, but I was trying to be lazy and I didn't. I don't know. I don't know why I did it that way now. That I mean, no, I mean, I think so. Okay. Ooh, what the? Okay. Okay, let's go over it one by one then, and then we'll kind of yeah, let's go over it one by one. The first one, yeah, I mean it's pretty straightforward. I did it in 1 minute 20 seconds, and when did I take? I think I added a couple of seconds for some reason, but I vaguely remember when I mean you'll probably see what I did, but only was a minute anyway. So yeah, I mean I think I still ran the code and test, but it was literally a library function in Python, so that was straightforward. For divisor, the trick part of this one is just to maybe this ranking includes the Chinese rankings. Because I think that's what I noticed from the last contest, but maybe I'm wrong. And that would be about right, maybe. Maybe they're just much faster about it. I don't know. But anyway, for divisors, yeah, this one, yeah, I mean, I got this also very quickly in about 2 minutes and 30 seconds. Did I mess up? Oh yeah, the only thing that I mucked up, and I had time to debug, which because I forgot to add the other divisor. But instead, I figured this will not be that inefficient because there's only 10,000 numbers, and most of the numbers are 10,000, and then it goes up to square root of 10,000. So that's like 100 times 10,000, so like a million or so. Um, yeah, so I didn't really worry about it, and then it's pretty straightforward after you find the divisor with the square root thing. Yeah, and if it's just do what the problem down, which is that if it's 4, then you sum it up, and then you sum up the sums. I wish they have another example just to kind of because maybe I have a typo that happens to fix one or to happen to be correct for this one, but yeah. Check. This took a long time, and a lot of time was spent on this roads thing. I was like, why are these the same? And I'm like, oh, okay, because you type them the same. That makes sense. But basically, I structured it like I would structure initially, like anyway, like a breadth first search, to be honest. Except for you can only go in one direction and you don't go backwards, which is what I keep tracking done, so that I don't go backwards. But otherwise, and also that the inverse of your road is on the road that you're progressing to. So I think that was the key thing. I mean, I feel like I knew how to do this very quickly, but I had just a lot of issues with implementation. Uh, and then if that's good, then mark it as done and then go. And then eventually return true if you could get to the endpoint. Otherwise, just return false after. So because you can only visit each, I mean, you could check this in multiple ways. Mostly the other way was that if this didn't move, then that means you're done because you're stuck at whatever square you were last at. But I don't know, I did the other way with, well, there's only all times C grid cells. So if you've already been to them, then you're done. Or like if you like that's the max number of places you could be, right? So that's how I did it. Yeah. I mean, I don't know what to say about this one, to be honest. If you watch my video, if you watch the live commentary, I'll go over my thought process. I don't think there's much for me to explain this one. I mean, the rolling hash was the only thing that I thought I needed to do. Um, and that would have been an interesting problem. I was just kind of doing this as a Hail Mary, and then it worked. So don't know what else to say about this one. My timing is probably terrible, but that's okay. A pass is a pass. But also probably means that the inputs are probably not that strong. But yeah, but it's not that hard to convert this into the rolling hash. I think initially I wanted to do, I don't know why I did a set first, but which went to a memory limited error. But I was also trying to do a memory efficient suffix array and then just binary search for the prefix, which I have done, or I know how to do in C in an easier way, but I have ran into some errors, which you saw. So I don't recommend that one. But yeah, if I had to guess, I think this is the intended solution, some variation of this, with the right is, I don't know, right times power of, I don't know, 26 to the x power or something like that. I don't know, y plus this times this thing, and then mod it. But I don't know. I mean, I would be a little bit reserved about it just because I don't know collusions. But that's how I would have done it, and I really should have done this one faster because I don't know. Don't know why I didn't. So, I mean, that's what practice and stuff like this gets you. Hopefully, you get to solve stuff like this. Maybe I am 191st then. I don't. These these rankings updated really, or like your rank is not your like your whatchamacallit is not your final rank because of the Chinese server, and maybe the Chinese is disproportionately fast on Q4, which I could believe, because that I mean, well, because this is well, I mean, looking at my solution, I don't think I deserve it either, so I don't know, but if I could have not deserved it much quicker, that would have been nice. uh, okay, cool. Overall, I mean, anytime you solve 4 problems, I'm not gonna feel that bad about it. and there's a clean sheet, as in I don't have any wrong answers, so feel good. I don't even know if I deserve Q4, but I mean, I guess rolling hash and I knew how to do it, so maybe that would have been okay, but I took way too long. Q3 as well, I just took a long time. There's no beating about it. I probably could or should have solved this at least 5 to 7 minutes faster. So definitely some potential for improvement. And I think I was just being careless a little bit with the roads. I mean, the rest of the code is so short that it can't be. I mean, it could be wrong. Don't knock on wood. But like, I should have double checked this instead of like I did a lot of print statements to debug, but I should have just double checked this. This was, I think what I need to do actually was because I keep on scrolling up and down. I think if I had two monitors or at least just two windows or something like that, just to have them side by side, that would have been much more obvious. But I was just being, I don't know, because I'm recording on stream. That's my excuse. I'm sticking to it. All right, friends. If you're still here, hit the like button, subscribe button, leave a comment. If you have any questions, let me know and all that stuff. See y'all out there and stay safe. Bye bye.